Today, I am delighted to have a conversation with Roberto Marcoccia, who has just been appointed as the new CEO of Effect Photonics. With headquarters in Eindhoven, the Netherlands, Roberto comes on board as the company enters a new phase of development. They have already grown from a small startup to a well-established global company with locations all over the world. Before we discuss Roberto's vision for what's next and his advice for other Optica members in our global network, let's explore his personal journey to the top position at Effect Photonics. Let me take you back to 1988, when Apple sold a kit to build your own Apple II computer that triggered Roberto's interest in electrical and later optical engineering.
So out of school, actually right before I finished school, I had the opportunity to join Condor Systems. And that's where I really got into RF radio, because everything in Condor Systems was collecting data through radios and then processing data. And about every 2 years, I got to do something different because the contract was done. So if I remember correctly, I was there for maybe 8 or 10 years. After I spent my initial career in RF communications, it was about the late 90s when optical started becoming very sexy. And I thought, okay, let me go see what this optical is, because I spent my entire career in RF. And I had the opportunity to join Caliant as, if I remember correctly, employee number 30. And that's where I started my journey in optical communications.
You were doing the MEMS-based all optical switching.
So I didn't work directly on the MEMS portion of it. I did all the system engineering. I owned system engineering. I owned the routing and protocol group and all the hardware that interface to the MEMS switch.
How were those times? How was from the time that you were at Cali and Networks, 2001, Silicon Valley area, the bubble burst?
In 2001, I went over to Stratolite Communications, started the journey of 40 gig long haul. When that burst that you talk about happened, knocking on customers' doors was quite interesting, because you knock on the door and you talk about 40 gigs and they go, well, come back in a couple of years. We had to really develop a group that can work very well together and really try to predict what will happen in 40 gig long haul communication. I would put luck in that category. After that freeze, as we came out of it, we had a product that was needed. And we actually won the AT&T National Backbone, working with Siemens at the time.
We are talking about the very beginning, the very beginning of Stratolite, before the acquisition of by Opnext. So you were at the very beginning of the company. So you were really setting up a new team in Datacom Telecom in 2001. I want to hear how is that experience? How do you find the people? How do you talk? How do you get people excited when everybody's wondering and worrying about their investment and worrying about the value of their shares?
So we had one room that we rented. I had the opportunity to pull in some of the engineers that worked for me at Wavespan. So this was an RF communications company. So I called them up, said, hey, I decided to go start this thing. Why don't you come talk to me? And the room was the company. At the end, it goes back to the relationships and the team that you have built in the past. And that once you start to be able to say, hey, person X and person Y and person Z are going to join, it becomes not that it's about the funding. They had some amount of confidence that I can make that happen. But if I can put this team together, that working together as this team, again, was the attraction, and that, hey, we'll work together. We trust that you'll go find the money. We'll make it happen. And that's how the team started. Even today at Effect Photonics, one of those engineers works for me since 1998. So it all goes back to having the right team in place, having the right set of people put together to make it happen. So that's how you start.
At the end of your time, Stratalight was acquired by Opnext. How was that process, and what kind of learnings did you get from that success story that the Stratalight became?
The actual process of being acquired is bittersweet. There's all the work that you've put in, especially the work that the team has put in. There's a reward for that. But at the end, you know that Stratalight would not be Stratalight anymore. So it's quite an emotional journey.
And then you became, not just you, but your team, you became worldwide famous for being the people who implemented the first real-time 100G coherent field trial with AT&T. And
Yeah,
that's 2009 or 10, something like this.
This was 2009 when we did that. So yeah, we set out on the journey to do optical coherent, I believe in 2007. And in 2009, along with AT&T and Cisco, we were able to demonstrate the world's first real-time. So we actually had a Cisco router connected to our blind side coherent. If I remember right, it was from New Orleans to Ellisville, Florida. And we actually looped back at Ellisville, Florida, back to New Orleans on an existing AT&T 10 gig line system. So yeah, that was quite an accomplishment for the team, AT&T and Cisco along with us.
And then you, of course, you left and you took the job that that made a big difference in the industry. You took the job at Juniper. You worked at Juniper for 10 years. Could you tell us a bit of your experience? You entered as a senior director for optical system technology, and you left as the VP of engineering of silicon photonics.
Yeah, so I knew Pradeep Sandhu from my days at Wavespan. I had some discussions with Pradeep, and Pradeep asked me to join. And Pradeep knew that at the time that optical would become very important for routing and switching systems. At Juniper, I did various things. As you mentioned, I started as a senior director in the optical systems side. I put together how to qualify optics. I did Juniper's first 100 gig coherent. I led the team to do that. Then in 2016, acquired Orion and commercialized the silicon photonics. And I'm very happy to see that OpenLight now has taken that and really making it an open platform. It is a great team, and I'm glad that they stayed together and did what they've done with it.
The acquisition of Orion, Roberto, gave you the opportunity to put your hands on photonic integrated circuits, in this case silicon photonics. What was your first reaction when you saw that people were going to integrate more and more functionality in a CMOS process using technology that was coming from the semiconductor industry to integrate photonics into a chip? How did you see that? Do you see this as a big paradigm shift, as something that the whole industry was doing, so Juniper had to do as well, as a differentiation factor? I'm really curious about what was your first reaction?
The first reaction is when Pradeep asked me, I need to make something that costs 25 cents a gigabit. And I said, let's see how we can do that. So in order to go drive that type of cost points, you need to have that level of integration. So not only in the silicon photonics side, but having the heterogeneous integration that Orion had, that they had developed, was the key, so that you can have the best of both worlds, indium phosphide in the silicon photonics. And regardless of the type of interface, indium phosphide is needed to generate light. So that was a key. And even why I'm at Effect is you need indium phosphide. So that took that journey on to
phosphide, the best material system to generate light at 1550 nanometers, which is the wavelength of choice for the datacom telecom in the coherent world. So at the end of the day, there is no other option than going there. And that's why in January 2021, you join a Dutch adventure and a group of people from the Netherlands and the UK and other locations in the world, but with a Dutch heart, you join a group of people from the Netherlands to develop indium phosphide-based photonic integrated circuits enabled transceivers. How did it happen? How did you hear about them, and where did you decide to take on this new challenge in your career?
After Juniper, as I started to look at what I wanted to do next, as I spoke to many of my colleagues in the industry, it was becoming very clear that coherent will go not only in the core, but it will go to the axis, it will go to the data center. That kind of sparked my interest again in coherent communications. At the end of the day, you need indium phosphide to generate a laser, the laser being one of the most important pieces of the coherent. In April of last year, we acquired the assets of Viasat, which is a team that I have worked with very closely over my many years of doing this. So it was very good to have that team join, and that's where where light meets digital. So take the light that was done by Tim and Budwin, the digital that was being done by the Viasat team, and if you really look at it, Tim and Budwin and the Effect team spent 10 years doing the indium phosphide. The Viasat team over the last 10 years developed many different DSPs that were sent out to the field. And after roughly 10 years, the marriage happened.
It was one of the most beautiful success stories that I saw in 2021. For me, Viasat is a company that we always engage with them in satellite communication, in broadband satellite communication. And when I saw that this acquisition was not only to explore the market, but mainly to get DSP knowledge and functionality into the Effect Photonics group. For me, that was one of the smartest moves that I saw in the last year in 2021 for the photonic industry. So for that, I would like to congratulate you. So now we are in a company with 100 people, working with some of the major players, both in indium phosphide foundries as well as assembly houses and OSATs. You mentioned Fabrinet and Jabil. The company still looks at coherent as well as direct detection. Is that something that you want to keep exploring as these two different flavors, or do you believe that the future is going to be coherent?
As the bandwidth demands increase, coherent will be the future. But with offering things like our ITLA, even on sleds and other things. So the focus will be going forward would be more on the communication side will be in coherent.
Coherent has a lot of advantages for longer distances, some of them for shorter distances as well. What is your take on this? Is coherent going to be used mainly for a set of distances, or do you think it's going to be used for both long and short?
Two types of products that are going out there. One that are meant for the performance, longer reaches, ultra long haul, that will still stay there. And then where a lot of I think focus will also be applied is in the shorter distances. What was today even data center interconnect, but when will coherent enter the data center? Will it be at 1.6? terabits, where you need that to maybe go 2 kilometers. The talk in the industry now with the low power 100 gig coherent to enable those access networks, the broadband connections, and being able to really take the work that has been done many years and really get it down to the lowest power per bit and the lowest cost per bit is where we'll spend a lot of our focus on.
When you bring the DSP knowledge to coherence modules, it brings you a differentiation factor. What I'm seeing now in the industry, especially in the area of Silicon Valley, I'm seeing that there is like a separation when it comes to bring photonics to a data center. On one hand, I see the companies who are looking at the pluggable transceivers, and on the other, I see the companies who are looking at the co-packaged optics world. And when it comes to pluggable transceivers, there are different solutions. We talk about the silicon photonics, we talk about the indium phosphide. What is, in your opinion, the benefit for indium phosphide for the pluggable transceiver world, and in this case for the coherent pluggable transceiver world?
So indium phosphide, the ability to be able to integrate multiple things together is where you gain the advantage. And if you think about like here at Effect Photonics, we are able to leverage those microelectronic ecosystems, the silicon photonics ecosystem from an assembly perspective, because we can integrate on the indium phosphide chip. And that both gives you a cost per bit and a power per bit advantage. And then you put that along with the DSP, and you get the best solution when it comes to those two different pieces. But as we talked about earlier, coherent, co-package always needs a laser. So light is always needed in those applications. What we're being able to do is we have the light, and we're able to integrate other functions with that light on our indium phosphide platform.
Sorry to ask so naively, but indium phosphide monolithic active-passive integration can provide the user can provide the user all the functionalities that silicon photonic does, and in addition, the creation and detection of light without the need of adding other materials. Is your vision that indium phosphide photonic integration will replace silicon photonics?
I don't know that it'll replace silicon photonics. There are different use cases that where the silicon photonics will fit quite well, and there's use cases where the integrated indium phosphide will work very well. In coherent communications, I believe it's the indium phosphide integrated photonics that will provide the best advantages. If you start to look at the other domain that you mentioned, co-packaged optics, that seems to be a very good domain for silicon photonics. So I think there'll be use cases for both.
You joined in 2021, Effect Photonics, but what kind of lessons learned do you think we have gotten from these very difficult, very challenging times of COVID?
Having virtual meetings is very productive, but one thing that I have learned is it never replaces a face-to-face building the relationship. So, and the first time that I was able to travel to the Netherlands and meet in person was fantastic. You cannot replace that, building that relationship with your colleagues. Without what we have today, it would be very difficult for me to do my job, being that I'm located in California. So I can do my job now very efficiently, but it does not replace going to visit my colleagues in Maynard, and we just opened up a Cleveland office.
Let's look at the future now. Let's imagine that we had this interview in 10 years. What is your preferred future? How do you How would you like Effect Photonics to look like, to be in 10 years'
Eh,
time?
So in 10 years' time, if you think about effect photonics, so we have an indium phosphide platform that we can generate light, we can integrate things at the photonic level. We have digital processing. If you start to think about other applications, you have to generate light, you have to detect light, and you have to process the data that you get from it. So if we were talking again in 10 years, my hope is that I would be talking about other applications other than optical communications that our technology can serve. I guess the worded advice that I would give it goes to team is put together a team that is better than you are. Your job as a leader is to make sure that the vision is understood and they believe in it. The rest of it is magic of how a team works together.
And with those wise words about building trusted teams, we wish Roberto Marcoccia all the best with the next growth phase for Optica member Effect Photonics. Join us soon for more insights from photonics industry leaders.